Okay, so here's how the week's going to go. We have 1.7 for 3 days, but only 2 days of notes or assignments, okay? So today, day 1, short notes, short assignment. I think you'll all finish it in class. Tomorrow, notes and an assignment, and I don't know yet how quickly that will go. I'll let you know tomorrow. And then Wednesday is a day 3 with no new notes and no new assignment. That will be a day to get any extra help from me, more one-on-one time with me because I'm not teaching, kind of like a review day like we had last week. That would be a day to catch up on any of the homework, ask for any help on any of the stuff from the last 2 days that you didn't get, or really any day, of course. You could also finish, 2 of you that didn't finish the AP Classroom College Board thing, you could do it that. And there's one other thing you could do that day. And you might notice that there's an online quiz that's going to open on Wednesday, on Wednesday it opens, and it closes the following Tuesday. So this will be our first online quiz in this class. Online quizzes are online, and this one happens to be on College Board. So the same place you went for your progress monitoring is the same place you're going to go for this quiz. And it's online, it's multiple choice. I think it's 9 questions. It's not very long. And when I do an online quiz, I encourage you guys to work together. You can use your notes. It's not cheating to use your notes. You're doing it at home. It's not like I'm going to know anyway, but I want you to use your notes if you want to. And you can work with each other or anyone in any of my classes. There's 130 of you taking this class. And I didn't make a different quiz for every class period, just so you know. You all have the same quiz. They might scramble the questions and the answers, but the questions will be the same. And so online quizzes are a great opportunity to practice, but also get, instead of just a homework grade, get an actual assessment grade, quiz grade. So I am fine on Wednesday. If you want to bring your laptop and work together, work alone, you can work on the quiz in class on Wednesday. Okay? But you have until next Tuesday to get it done. And there's no makeups on online quizzes. So when they open, whatever date they close on, it's midnight or 11:45, I should say. So it's always, I open them 7 a.m. on the opening day and close to midnight on the closing day, always those same times. So you can work on it anytime in there. And if you want to go in and go out, you can. Just don't hit submit till you're ready for it to grade it. Okay? But it'll save your answers and everything. All right, so that's coming up. Our first online quiz. All right, any questions before we start today's stuff? Okay. So we're working with rational functions for the next little bit. Rational functions have lots of little parts to them. And today we're going to break down a little bit. Tomorrow kind of do a little bit more and put it all together. So what a rational function is, so notice we're using R for rational, is it's a polynomial in the numerator and a polynomial in the denominator. That's why we used n and x. And you can look, here's an example of one right here. Okay? So you have a polynomial on the top and a polynomial on the bottom. And a big takeaway here is that the denominator cannot equal 0. That's really, really important. That's what makes these kind of annoying because it causes problems for us in our graphs and stuff like that. But it should make sense because we know that you can never have a denominator of 0, right? That's bad. You can have a numerator of 0, though. Just remember that. 0 on top is always fine. 0 on top is fine. And I always get students that mix those up, and so I just want to show you that you can always ask the calculator for help on that. If you do 0 divided by any number, it's going to give you an answer of 0, because it's allowed. 0 on top is okay. But if I do any number divided by 0, it gives me an error, because you can't have a 0 in the denominator. Okay? So that should be a concept we kind of already know. No zeros in our denominator. So what we're going to do is find the domain of a rational function today. So we're really just doing 2 things today. We're finding the domain, and then we're going to talk about one of the types of asymptotes. So I don't want to get ahead of myself, but this is one of 2 types of problems. So to find the domain, we have to ask ourselves what x values make this a true equation, make it good. Or it might be easier to say what numbers cause a problem for this. And that would be anything that makes our denominator equal 0. So to find the domain, we're going to factor first, okay? There's no factoring in that numerator. And by the way, we don't care about the numerator. The numerator is allowed to be whatever it wants. We don't judge that numerator. It can be a 0, it can be a 5, it can be a negative 5, okay? It's the denominator that we're worried about. Anything that would make my denominator 0 is going to be a problem for our domain, okay? So what we have to do is factor. So I told you at the beginning of the year how important factoring is to this class, and I don't think I have told a lie because you've seen it a lot already, okay? You're going to see it a lot throughout the year. So you have to know how to factor. Whether you can do this in your head or you make a chart or you use whatever method that you've learned and you like, I don't care. I just want you to be able to factor. So if you remember, this is the chart problem. And again, I don't have to see the chart for work, okay? A lot of you can probably do this without a chart. But what I'm doing is multiplying 1 times 12 and getting 12, and the b value of -8, and then asking what two numbers meet both criteria. And if you're still having trouble finding those numbers, an easy way to do it is just to come up with the two numbers. Forget about signs. Like, I know 6 and 2 can make a 12, and 6 and 2 can make an 8. So I'm just going to start by putting those numbers, and then I can play with the signs. And if I mess up, maybe those weren't the right numbers, I can cross them out and try something else. This is like your workspace. It's okay to make mistakes. All right? So how do I make a -8 with a 6 and a 2? Yeah, Rex, they'd both be negative. And that's true, right? And then you always want to make sure it works in both columns, and of course it does. We never want, was it Rex that said that, or was it? Yeah, it was? Okay, I thought maybe you guys said it wasn't him. Sorry if it wasn't. But always make sure it works in both columns. A mistake that students make on factoring is they make sure it works in one, and they don't check the other one. They just assume it does, and that's where we get into trouble. So always make sure it works in both, whether it's in your head or you write it out. So when I factor this, I get those two factors, right? So I'm just going to go over here and put them in the... So that's factored. That's the first step. You have to factor it. And then you look at your denominator and you say, okay, what numbers would make my denominator 0? So whether you write it out or not, again, I don't need to see the work here, you're thinking, what would make my denominator 0? Because I don't want it to be 0. And so you're finding basically the zeros of your denominator, right? X can't be 6. That should make sense. 6 minus 6 would be 0. That would give me a 0 on my denominator. Bad. And X can't be 2. And that should make sense. If I plug a 2 in here, 2 minus 2 is 0. I would also get a 0 on my denominator. So these are what I call my problems. Those are problem numbers. 6 and 2 are bad. Every other real number on the number line, from left to right forever, we can use any X value except for this one or this one, okay? So the way we're going to write it is in interval notation. And this is just another thing I want to show you in case it helps some of you. You don't have to do this part, but if I made a little number line of these two numbers, least to greatest, I would say, okay, visually, 2 and 6 I would have open circles on, right, because they're not included. But I can use all of the numbers to the left of 2, all the numbers in between, and all the numbers to the right. So that's basically a visual of all real numbers except for 2 and 6, right, excluding those with an open circle. So let's put it in interval notation. I would have left to right, that's what this arrow is negative infinity, right? Negative infinity all the way up to 2, but we're not including the 2, so we put parentheses. Union, we want the numbers in between 2 and 6. And then, notice the parentheses, because 2 and 6, even though they're the endpoints, if you will, they're not part of the domain. So that's why we use the parentheses versus brackets. And then 6 to infinity. And that would be your domain. Okay? Now, sometimes I get students, so I'm just going to throw it out there, will ask me, but why use 2 and 6? Why not use 3 and 5 and put brackets? Doesn't that mean the same thing? Because we don't want 2 and 6, but what about the numbers, on either side? And the answer is no, because remember, there are numbers in between 2 and 3. I can't start at 3, otherwise I'd be leaving out a little portion of the number line. These are just the whole numbers, 2 and 6. But there's 2.1, for example, 2.5, 0.001, whatever. Teeny tiny decimals in between 2 and 3. Okay? So we just use the parentheses. Right? Do we get that? All right. Skip over, and we skip around a little bit today. So just understand there's a reason for it. We go back and do some of it tomorrow. Remember I told you there's 2 types of problems. And we'll do another one just like that in the notes in a second. The next thing we're going to talk about is asymptotes. So asymptotes are probably something you never heard of until you got to Algebra 2. And I don't even know if your Algebra 2 teacher covered it. I don't know. But asymptotes are imaginary places on your line. Let me back up. The reason we have restrictions on our domain, we already talked about it, is because 2 and 6 would make our denominator 0. We all know that algebraically, we can never have a 0 in our denominator. So we're excluding 2 and 6 from our domain. I think we understand that. But understand this. When we go to graph a rational function tomorrow, when we graph it, our graph has to match what this is. In other words, a graph is just a picture of the algebraic form of our answer, okay? And so somehow on our graph, we have to show that 2 and 6 are bad. They're bad. They cause a problem for our graph. We can't touch them or cross them because they're not part of the domain. We have to exclude them from our picture. And the way we exclude numbers on a graph is through something called holes and something called asymptotes, okay? So tomorrow we'll learn about holes and vertical asymptotes, which come from this exact idea right here. Horizontal asymptotes are kind of separate. Either way, a vertical asymptote is a vertical line, right? And a horizontal asymptote would be a horizontal line. Bottom line is there are places on our graph that block the graph. You would get really close to an asymptote, but you can't cross it, you can't touch it. So they're imaginary lines. So horizontal asymptotes are a little bit separate. So we're going to cover those today. They're nice and easy to go over. So there's 3 types of horizontal asymptotes, and we don't have to factor anything. We simply look at the degree of the numerator and degree of the denominator. And remember what degree is. It's the power, okay, the biggest power. So for example, if the degree of your numerator is 1 and the degree of your denominator is 2, well, 1 is less than 2. So if the numerator's degree is less than the denominator's, and it doesn't have to be 1 and 2, it can be 5 and 6 or 10 and 3, whatever, okay? We would have a horizontal asymptote of y equals 0. Because remember I said it's a line? Horizontal lines all start with y. Y equals a number. Verticals are x equals. And we'll do those tomorrow. But y equals 0 would just be the x-axis. Y equals 0 would be right there. Okay? Let me give you an example of what it looks like. So if I gave you this problem and I said, what is the horizontal asymptote, you would go, okay, the numerator's degree is 1, the denominator's degree is 2, and 1 is less than 2. So my horizontal asymptote would be y equals 0. There will be a line on my graph, imaginary, that I might have points all around it, above it, below it, but I can't touch that line of y equals 0. Okay? That's one of them. The second one, if the degree of the numerator is the same, if they equal each other. So if like the degree of the numerator is 3 and the degree of the denominator is 3. Let me write the example first, and then I'll tell you what it is. So the degree of the numerator is 2, the degree of the denominator is 2. So whenever that happens, what? Sorry, what did you say, Ashton? Got it? Okay, we are going to form a ratio. Ratio is fancy talk for a fraction, okay? The ratio of the leading coefficients that are known as A and B. So in this case, 8 is A and B is 2. So we have a horizontal asymptote of 8 over 2. Let's simplify it. That would be y equals 4. Okay? So when they're the same, you go to the leading coefficient. So understand the language. Degree is the biggest exponent. Leading coefficient is the number in front of the letter that has the biggest power. So that's where I got the 8 and the 2. Okay? And the last one is if the degree of the numerator is greater than the degree of the denominator. Like if we had a 3 and then a 2, right? 3 is greater than 2. Whenever that happens, we have no horizontal asymptote. There's an example. The degree of the numerator is 2. The degree of the denominator is 1. And 2 is greater than 1. So how do you remember these? Okay, so I'll tell you that after and we're going to practice them here in a second, but this middle one, no one really messes up. Once you do a couple of these, everyone remembers this middle one. It's the first and the third one that students confuse all the time. And so would I, all right? And so whenever something is just like, this is kind of just rote memorization. This is what I call like note card memorization, like where you put the type on the front, you check yourself on the back. You guys make little flashcards, note cards all the time. Because there's not really a special, it's not really learning anything, it's just kind of knowing which one is which. And I'm going to tell you my trick for knowing it. But I also want to talk to you about memorization when it's something, like the unit circle, for example. When we get to unit 3, that's all trig and unit circle. We start it in January. And you'll never hear me use the word memorize with the unit circle. We don't memorize it. If you tried to memorize it like note card memorize it, you might know it long enough to take a quiz a half hour later, but then it's going to be gone. With the unit circle, that's learn it, then you know it. You don't memorize it. Okay, so you'll hear me talk about that. But this one, there's really no other way. But let me tell you how I memorized it, because I'm horrible at memorizing things, so I like to share with you guys my method of memorization. If it works for you, great. A lot of people are like, I don't even know what she's talking about. I already have it memorized, moving on, okay? But I'm just sharing it because I have a hard time memorizing. And I think back to the most simple graph I ever learned how to graph, and that's of a line. And think about how you graph lines your whole life until Algebra 2, and all of a sudden, you hear this word asymptote. Or maybe this is the first time you're hearing an asymptote. The reason you never heard about asymptotes when you graphed a line is because they don't have asymptotes. Lines don't have an asymptote. For example, let me just make up a line. There's a line, right? This has got a degree of 1, right? Linear, degree 1. If I wanted to make this into a rational function, I would have to put a polynomial on the bottom. And since there isn't one, I could just call it x to the 0. Anything to the 0 power, by the way, is 1. So this is just like saying 3x minus 1 over 1, which is just 3x minus 1. But when you see it like that, I want you to notice the degree on top is greater than the degree on the bottom. That's always going to happen with a line, always. And so if I remember that lines don't have an asymptote, I can kind of tie that in with this type of problem. The minute I see something bigger on top than the bottom, I always think of a line, which always has a bigger power on top than the bottom because there isn't one. And I remember it that way. And so we're going to do 3 examples here, and I'll bring that up to you guys again. So when you get to the homework, it's 13 through 16 are these types of problems, just so you know. Same exact directions, everything. So to find the horizontal asymptote, we don't have to factor. We don't have to do any of that. We just look at the degree. So what would the degree be of our numerator, guys? Not 1, 0. There is no power. Okay, just so you know, let me address this, Rex. The degree has to come from a variable. If you don't have a variable, it's like calling it x to the 0. Okay, so 0 is less than 2. Right, degree is 2 on the bottom. So your horizontal asymptote would be y equals 0. When it's less on top, that's not a line. Okay, it's y equals 0. And another mistake students always make is mixing up, because tomorrow when we introduce vertical asymptotes, it's going to be x equals something. So I try and remind you which one goes with which by saying hey, right? H-A-Y. Hey, and then tomorrow it's going to be vax, V-A-X. You'll see. All right, next one. The degree is 1 on top and 1 on the bottom, right? When they equal each other, then I have to take the A and the B. So A is 3, B is 1. It's just the leading coefficients. So 3 over 1 just equals 3. There's that A again. So horizontal asymptote, when the degrees equal each other, just take the leading coefficients, 3 over 1, or 3. Good? And then the last one, the degree of the numerator is 2, which is greater than the degree of the denominator, which is 1. This is where I remember my little trick. When the top is bigger, it's like a line. So there is none. Okay? Okay, let's just do one last example, exactly like 1 through 8 on your homework will be. And that's example 4. Now listen, I'm almost done talking, then you can go work on the homework, ask for help, but please listen as I go over this one. Tomorrow we're going to find holes and vertical asymptotes, x-intercepts, we're going to add y-intercepts to it. But today, for this problem in the notes, and just like the homework, all we're going to do is find the domain. And this is just going to be like the homework 1 through 8. Same exact directions on 1 through 8 in the homework. So 1 through 8, find the domain, 13 through 16, which I'll put it up here in a second, but 13 through 16 is just finding HAs. We are skipping around a little bit, so I'm trying to be a little bit more detailed in my directions here. Okay, so tomorrow, like I said, we're going to go deeper and find some more interesting stuff out about this. But it also always starts with the domain. So we would have to do this step first tomorrow anyway, so we're just going to do it now since we're learning that. And we're going to factor the numerator and the denominator, okay? And the first step of factoring is always to factor out a GCF. And my numerator has an x in common. So factor out an x, and that leaves me with x minus 3. You should be able to do the distributive property there and check it, okay? The denominator also has a GCF. What would it be? 3x, good. And then you divide both of those by 3x, whatever's left. Okay. Now, all we're going to do right now for today's assignment is look at the denominator to find what x can't be. All right? Tomorrow, that numerator is going to need to be in factored form because the numerator will tell us if we have vertical asymptotes or holes. So hold off on that, but at least have it factored so it's ready to go tomorrow. So we're ignoring it for today, though. So remember, you are going to get solutions, or in this case, non-solutions, from your x's. I don't need to see this work. I'm just showing you. So the reason I say that is because, just as a side note, if it was just a 3 out in front of the x plus 2, I don't get a 0 from a 3. I can't set 3 equal to 0 and solve it. I would only get 1 0 from this. Here, I'm going to get 2 of them. Okay? So x can't be 0, and x can't be negative 2. Right? Those are my 2 numbers that x can't be. If making the number line helps you, go right ahead, but you don't have to. I'm going to show you without doing the number line. So the domain would be, we always start all the way to the left, negative infinity, up until the smallest number. Right? Every number on the number line until we get to negative 2, but we don't include it. Then we go from negative 2 to what? 0. Yeah. And then we go from 0 to infinity. So it's pretty long, but it shouldn't be difficult, right? And the more x values you have in your denominator, you could have 5 numbers that x can't be. Your domain gets really, really long. But it's the same process. You're just going left to right, right along the number line. Why is 3 not excluded from my domain? Why is 3? Does anybody know? Because it's in the numerator. That's right. The numerator can be 0, Rex. The denominator can't be 0. Remember in the beginning when I said, okay, so we didn't include negative 3 here for this first example because 0 is allowed on top. It's the denominator. The fact that we have a fraction, fractions cause us problems, right? We hate fractions. Here's another reason to hate fractions. The minute we put fractions in our graphing, we've got asymptotes and holes and numbers that x can't be. But x can be negative 3. That's okay. X can't be 6 or 2. Okay? Good question. Right? All right, so let's go to the homework, and I'm going to do 2 of them with you, and then you should have no problem finishing. Grab this. All right, so okay, so ignore all the other lines and directions. 1 through 8, we're just finding the domain. We're getting prepped for tomorrow, basically. And then 13 through 16, that goes into practice set 2. Don't let that bother you, okay? We usually have day 1, day 2 very separate. Sometimes there's going to be overlap, especially when I skip around like this, okay? But it just continues. 1 through 12 is on day set 1. 13 through whatever is on set 2. No big deal. All right, so I'm going to do 1 and 5 with you just to get you started. But understand, you can ignore all those lines. Only thing you're doing is the domain on all these problems, okay? We're going to be doing more of it tomorrow, but today is just domain. And the first step is always factoring. We have to factor. Let's go ahead and factor the numerator and the denominator. GCF. And recognize that denominator, guys. That's the difference of two squares. X plus 1, x minus 1. Okay? Now, we factored the numerator for tomorrow. We don't look at it today. Because remember the conversation we just had, 0 can be on the numerator. So the numerator has nothing to do with our domain. Okay? It's this denominator. We should know that x can't be -1 and 1. Right? By looking at those? You don't have to set them equal to 0 and solve. -1 and 1 are our two problems. So then, negative infinity to -1. And there are numbers between -1 and 1 besides 0, right? There's lots of decimals and stuff. Okay? That's all you're doing for 1 through 4. Same with 5. It just looks different, so I thought I'd do number 5 with you guys too. Oh, I got something. All right, so look at number 5. Any question on one? I'm doing a 5 with you. It's a homework problem. You might as well skip to it with me. Nothing to do in the numerator. That happens a lot, so no problem. And then my denominator is a chart problem. And 6 and 5s in the chart can be tricky because 2 and 3 make 6, and 2 and 3 make 2 and 3 or 5 and 1, right? You could have 2 and 3 make 6 or 5, and 5 and 1 make 6 or 5. So you have to make sure you really check your signs here. And so there's only one way that this will work, and that is if both the -2 and both numbers are negative, right? Because a negative plus a negative, negative, negative times a negative, positive. So factored would be x minus 2, x minus 3. What can x not be just looking at the denominator? 2 and 3. Just the denominator. So I'm going to put the key up. Just know, my key has all the work for tomorrow done on it too. You just tune it out. You're factoring domain. That's it. So ignore all the other work and stuff there, because it'll confuse you up all. Okay? But you should have no problem finishing this in class. And so there's 2, 3, and 4. I will flip it for you guys in a few minutes. Did it record?